Hey, we're going to be finding the derivative of f of x, and we're going to be demonstrating on how to do that by using the quotient rule. And then once we do find the derivative, we're going to take 6 and plug it in and see what the slope of the tangent line would be when x is equal to 6. So I'm going to consider my function here in this formula f of x equal to h of x over q of x. And I'm going to consider h of x just to be top and q of x to be bottom. So we take the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. Now, I should probably have rewritten this problem, but I didn't. Hopefully you can follow this. This can be rewritten up here. The numerator is x plus 1 raised to the 1/2 power, and the denominator x minus 1 raised to the 1/2 power. So we take the derivative of this, and that 1/2 goes out front, rewriting, subtract 1 from the exponent, and 1/2 minus 1 is a negative 1/2, and then we rewrite the bottom minus the top times the derivative of the bottom. Right, so this is x minus 1, remember, raised to the 1/2 power. And 1/2 minus 1 is a negative 1/2. All over the bottom square. So I'm going to rewrite this. This is x minus 1 to the 1/2, and that's where this is coming from here. And because it's a negative 1/2, we want to take it down into the bottom. So we have x plus 1, and I go ahead and put it back into radical form. We do the same thing over here, leaving this in the top, times, and rewriting this here. This is 1 over the square root of x minus 1 because of the negative 1/2. Now I'm going to take this up here to the top, kind of clean it up a little bit, two separate fractions. This x minus 1, this can be rewritten as 1 over x minus 1 times the numerator. So now it looks like I'm want to join these together and get one big fraction, and in doing so I need to get a common denominator. And so I'm going to multiply x, the square root of x minus 1 on top, and the square root of x minus 1 on bottom here. And an x plus 1, we don't have that over here, so I go ahead and multiply the square root of x plus 1 on top and the square root of x plus 1 on the bottom. Now we have a common denominator, and we just add the tops. Now, the square root of x minus 1 times square root of x minus 1 just gives you x minus 1. And same follows here. The square root of x plus 1 times square root of x plus 1 gives you x plus 1. Now we can go ahead and simplify this down up here on top. And if you distribute this negative across, the x's cancel out, and you end up with a negative 2. Because you have negative 1, distribute this across this negative 1, you have negative 2. But I have a 1 written up here on top. We have a negative up here in the top, but we have a 2 down here in the bottom, so you see the 2's are canceling out. And so you're just left with a 1. However, the negative didn't cancel out, and I go ahead and bring this out front. And of course our common denominator, in this case, now don't forget the x minus 1 over here. That's where this is coming from here. And then we have the square root of x plus 1 and x minus 1. So we have found the derivative, finally. Now what I don't do in the problem, though, is find f prime of 6. So you just take 6, plug it into the derivative, and that would give you the slope of the tangent.